So, is this recording yet? Oh, I believe it's recording. I hope it is. But anyways, what we're going to talk about today is resources, and we're going to do an example that's a bit more of a real-world example. We're going to take something that's seen very commonly in iOS, and we're going to try and adapt it to Android. And in Android is something that cannot be done, and you have to do it custom. So, but first, let's start off with resources. And let's start at the beginning. Okay, so I'm sure you've all gone through your Stack Overflows and stuff like that, and you've always seen like XML, like everything's in XML. There's no programmatic example. It's the most annoying thing on the planet. But luckily now you can use resources, so I'm going to show you how resources are used, and we're going to, on our example, I'm going to try and use XML as much as I can, because honestly it's really quick. Although many times to do anything custom you still have to go and do it programmatically, so if you know how that works it's better. But sometimes you just want speed, and resources are one of the ways to do it. So this is just an overview of activities. We all know kind of how it works by now. There's a life cycle. There's certain callbacks that are called in a certain sequence depending on which part of the life cycle an activity is in, right? Now resources. Resources is Android's way of, it's similar to iOS with storyboards. What it does, among the things it does, one of them is it allows you to quickly set up a layout, set up the look and feel of an app without having to do too much code, and it's actually really simple. It's one way to do it. It's not the only way, but it is very quick and easy. Other things that the resources allow you to do is the whole concept of resources is you write it once and use everywhere, right? And there are many different things that you could do. So there's layout resources, which is for views, things like that. There are drawables, which you've all used before by now. It's your images, image assets. You have values, and among these values you have strings. This is how you localize things. You have dimension resources, which is what it sounds like, dimensions. Style, animator, things like that. You have quite a few, actually. In fact, this is from the Android docs. You have animator at the top and anim, which there's two different types of animations in Android. Really weird. One type of animation, the simpler kind, it moves the view around. It moves what you can see around. I wouldn't call it the view. It moves what you can see around and animates that part. But on-click listeners and everything like that is actually back in its original position. So if you were to move a button and animate it to the top and try to click the button at the top, it's not going to work. You have to click it in the invisible spot where it used to be. So that's the old school way of doing animations in Android. There's a new way, which is, I think they have it in the animator, yes, in the animator folder. So anim is the old way, animator is the new one, and these are called object animators. And this is exactly what you would expect an animation to be. If you move a view from one place to another and animate it from one position to another, all the properties go with it. So all the clicks and everything else is there. It's a little more complex to use, but it does what you want in the end. And really, once you get the hang of it, it's not too bad. You also have color drawables, so you can define your own custom colors. It's essentially in hex format. There are some other ways to do it. Drawables, which you've all used. Layout, which we're going to review a little bit today. Menu items, which deal with your action bar. So I'm sure you've all seen it whenever you auto-generated code in the IDE. You'll see stuff for the menu. You have raw, which can be for assets and things like that. But really, there's a dedicated assets folder for like fonts and things like that. It works a little differently, but that one is better to use. So raw isn't used quite as often, but sometimes you need it. For example, if you wanted audio files, things like that. Values. This one's pretty big. You can define arrays, colors, dimensions, strings, and styles, among other things. And the final one is XML, which is really useful. Like, there's a very easy way to do settings and preferences using resource files. We won't go over that today, but it's pretty cool. It's something that you can look into. It's really not that complex. But yeah, that's resources. There's quite a bit to it. So here, what we have is, you can see the menu to the left has drawable, values, values-JA, values-PT. And that dash, 2 letters actually corresponds to localization. So normal values corresponds to English because, Android's English. Then we have -JA, which corresponds to Japan, -PT, which corresponds to Portuguese. And what the Android system will do is it'll figure out which area you're in, which region you're in, and it'll access the correct values folder. And we'll see a little example on how that works. So here we have it. Here's that example. We have values, values BT, values JA, right? 3 different code snippets, and you can see that the XML has string name and some name that represents that resource, right? And it's the same across all 3. You'll see app name, app name, app name, hello world in all 3, action settings in all 3. But what's different is the content of each of those resources. You can see in the normal values, no dash anything, you have, what's that say, sprites, hello world, and settings, right? And in the other one, you have that same thing, but it's in Portuguese. And in the far right, you have those same values in Japanese. And this is how you localize your app. Instead of having to search through your app for every single place that you put, a string, if you define it as a resource file, all you ever need to do is take your resource string file, take it to a translator, or if you know the language yourself, and then just translate each one. Throw it back into the app, and suddenly you have your app in several different languages. So that's really cool. And you can see, maybe some of you used that before, the get string, and then you pass it to r.string. Whatever your string resource is called. Next, we have drawables, and you've probably used these before. Matt generally has you to just get rid of all of them and use a single drawables folder, which is fine. That's what we need for this class. Sometimes you don't need several different drawables, and sometimes the resolution isn't quite what you want. But the IDE actually has a very simple way of creating image assets. If you right-click on the resource folder, there's a create image asset icon. You click that, you define what the PNG or JPEG, whatever it is that you want, and it'll actually create 3 different resolutions for you, or however many resolutions you need, which is really nice. So you never have to worry about it. And really what it does, what the drawable is depending on the size or the resolution capacity of your device, it'll pull the correct drawable out. So if you have a pretty small device, then you're probably line the MDPI, the medium, right? So it'll just pull the medium resource file. It's smaller. It doesn't take up as much memory, things like that. So it loads up quicker for devices that don't have the resources for it, and et cetera, as the devices get bigger. Obviously, on a bigger screen, you can't have this crappy little resolution icon. You need something that actually looks good on a bigger screen, and that's what the drawable resources do. Next, you have layouts. Now, this is an example of how layouts work. You open a tag, linear layout, and then you give it some attributes, and that's what the Android ID, Android layout with, that's what those are. They're called attributes. And this essentially defines different things of that view. So obviously width and height, that should look very familiar. They're both match parent. So that's exactly what goes into the layout params. That's what it is. And then you have orientation. This is specific for linear layout. You can change the orientation with just that attribute. And then anything that goes within, and then you have content that goes within it, and that it essentially just, it's the tree of views, right? And that can go as deep as you need it to go. And that's how XML layouts work. It's just a tree of views, a tree of whatever you want to put in there. And it's really nice because all you do is you open the tag, you give it the parameters real quick, and your IDE has autocomplete for all of these. So it ends up being a very quick process. And then to bring it into your project, it's just a quick little line of code, and I'll show that in the example today. You can also create custom layouts, and custom layouts are actually really nice, but most of the time you don't do custom XML layouts because usually it's just for library code and things like that. It's a lot of times it's just something you're going to use once, or it's something that people are just going to play around with programmatically. Very rarely do you have someone who actually defines the attributes for an XML layout, and that's exactly what this does. That shape view at the bottom, the one with the really long name, shape view, it has 2 custom attributes, and you can tell the difference because it says custom : side count and custom : shape color, and those are attributes that you have programmed into this layout. How do you do that? You create an attributes XML, which is the bottom rectangle here. It says resources, declare by stylable name, and et cetera, et cetera. In here you have what the attribute name is and what it accepts. And it says there integer and color. And that's how you create an XML file with custom attributes. Now, there's still more to it, and in code, to be able to use it in the constructor, you have to basically go through that. Very, very strange and obscure way to go about it, but in the end it can be very powerful. So if you have some view that you know a lot of people are going to use, it's very nice to be able to control the view through the XML and not have to type out the code every single time. So, you know, it's something to look into. There's lots of tutorials on how to do it. It's a little convoluted because you can see it's typed array with this giant name at the end and then side count with this giant thing at the end, and everything's just really weird. But in the end, it can be a very, very powerful tool. Worth looking into if it's something you want to do. Most of the time, you don't need to. But anyways, let's jump into the code. So, where do I have my... So what we're going to do today, and unfortunately, I'm not going to be using the emulator because the emulator is a little too buggy for this. So I'm going to be using the document viewer. So when you go back and try and go through the video, unfortunately, you won't see the example on the side, but I hope that you'll remember more or less what it looked like. And I'll also put up the code. That way you can see the finished version and see how it works. So what we're going to try and do today is called a sticky header. Now in iOS, how many of you have iOS devices? Yeah, a good chunk of you. Yeah, I do too. And in iOS, it's very common to see sticky headers. And what's a sticky header? Let's say you have, for example, here you have this banner at the top in colored purple, some bar which is sticky here. It's usually some button bar of some sort or something like that. Facebook has it. And then you have content that goes below it. And what happens is as you scroll up, the bar sticks to the top. And you'll keep scrolling through, you'll reach the end, and then as you scroll back up, it still stays at the top until you get to the very top where it comes back down and displays the banner. So it's a really nice, it's quite common nowadays, but it's a really nice thing, and unfortunately Android has absolutely nothing to do this. You have to do it custom. So how do you do it? And that's what we're going to do. And this code here is actually taken straight from an example. They do a very, very simple example using a scroll view. Unfortunately, when you're doing real-world things, you very rarely use scroll views, because when you use a scroll view, it's because you know what's going to go in it. The content's not going to change likely. And if you do, it may change, but it's not as dynamic as if you had to use a list view. So in a list view, you could do the same thing, but the demo does not show you how to do it. So for a project I had, the iOS version actually had the sticky header. And when I had to do it in Android, and I was like, okay, great, now how do I do it? So I figured out how to do it, and I want to give this to you guys because it's a really cool UI tool, and in the end, it's not too complex to figure out. So that's what we're going to do. We're going to create that, and we're actually going to interact with a model backend. So we're going to pretend that someone else wrote the backend, the model, and we're just going to interact with the data and throw it into a list view. Whatever's in there is going to be displayed on the list view, and that's usually how it goes. Someone will do the backend, and someone else will do the front end. So you often don't know what the data is. You just need to display whatever they give you. So, here's what we're going to do. We're going to create a new project. We're going to call it Sticky. And that's fine. I'm going to create a blank activity with a fragment, so it's going to generate some code for me, which is okay. I'm fine with that. And then I'm going to name that Sticky. And before we start, I'm going to grab this little folder here, which I've already created some stuff for. I basically created a model already. Alright, so like I said, we're going to deal with XML today. We're going to try and use it as much as we can. So we have a relative layout here. Relative layout, can we use relative? Yeah, it should be fine. Okay. Actually, yeah. So here's what we're going to do. We have this relative layout. We're going to get rid of this. And I just want to make sure it's all right. Yeah. It shouldn't matter. I'm going to change this to frame layout because it's always worked for frame layout before, and I don't want to change it. So, frame layout. So what frame layout does is everything is just going to be placed on top of each other. There's nothing you could do about it, and it just goes on top, which is fine. So what we're going to do here is we're going to create a list view, It's going to ask for a width. We're going to say match parent. And a height, match parent. I've just defined the layout attributes. Awesome, right? Didn't have to do anything else. And next, I'm going to create a button bar. So we can see over here on our little demo here that we have this sticky, which really doesn't do anything, but I want to create a button bar out of it. So let's create a button bar. To create a button bar, I'm going to make a linear layout. I'm going to say width is going to be match parent, and height, I'm going to say it's 80 dp, because I feel like it. I think that's a good height for a button bar. And I'm actually going to get rid of some of this padding. So one really cool thing is resources. The height of the button bar is going to be very important to me, and I'm going to want to know what that is, and I don't want to have to remember what it is. I want that resource to be in a single place and never have to worry about it again. So what I'm going to do is I'm going to hit Alt-Enter, and it's going to open up a context-sensitive help menu. In this case, one of the first options is Extract Dimension Resource. And this is going to be very useful. So what this is going to do is I'm going to give it a resource name. I'm going to call it Sticky Height. And this automatically created a resource for me in the resource directory. So if we go to Values, Dimensions, and you can see right here, Sticky Height, 80 dp. So now if I ever want to know what that height was in anywhere else in the app, I just need to reference this area. And I won't have to make sure that I got the wrong value or anything like that. I know what it is. If I ever need to change it, I change it in that one space, and it updates the rest of the app. So now that I've got that height, let's see, I'm making a button bar here, so let's make the orientation horizontal, and let's give it an ID of button bar. Okay, and in here I'm going to have two buttons. One is going to be 0 dp, and the other is going to match the height. So I'm going to match the height, give the width 0 dp, and I'm going to give it a weight of 1. Can anyone explain why I did that? Exactly, yeah. So I give it a height of 0, or a width of 0, because when the weight, so essentially both views are completely invisible. And then the weight attribute comes in and it says, okay, what is left over? Both views are 0, which means I have the entire area to lay out the rest of it. And because I gave them the same weight, it's going to split the area evenly between the two, which is great. It's exactly what I want. So now you can see here that it's highlighted both, that I can highlight the area. So if I click here, the button, it'll highlight that button and it'll highlight the other button. So it's a nice little tool there, right? So I'm going to give it a text. I'm going to call this one grid, and I'm going to call this one list. And as you can see, updated it, grid and list. Now, the proper way of doing this, because it's a UI-facing component, I want to create a string resource. So Alt-Enter, extract string resource, I'm going to call it grid button. Same thing here. List button. There we go. And now that has automatically created string resources for me. Great. Now, I want this to look like a button bar. And Android actually has a style for button bars. And we're going to go over what styles are in a little bit. So there's a style attribute here, and it's going to be Android button bar. And you can see there that it styled them however Android decided what a button bar should look like. To be honest, I think it looks disgusting and ugly. So we're going to define our own resource, our own style. So we're going to go into the Values folder and Resources, and we're going to go to Style. And we're going to create our own style here, and I'm going to call it button bar. And here is how you define the styles for your view. You open up a tag and you say item, and if you see here, these are very similar to the attributes you had in the XML. And really, they are the attributes from the XML. So I just defined a text size of 20, which is the same thing as if I went in here and did text size 20. So SP is better for strings. It's just the way to do strings. It's basically the same size, but it behaves just a little bit differently so that it works better. It's just the recommended way to do it. So next so I have a text size. What else do I want to do? I want the text color to be, what color do I want this to be? I'm going to access an Android resource, so Android color, and they have a blue, hollow blue light. That's the color I want for my text. I want the font, item, font family. I'm going to pick it sans serif light. I'm also going to define another one, which is, I want it all caps. So no matter what, I always want it to be caps. I want the background color. Background. Why doesn't this, where is it? There you go. Background color. And I want it to be white. And Android actually has a white color, but just to show you guys how to define a color, I'm going to go ahead and make one. So we're going to go here. There's no colors XML, so I'm just going to create one. Colors. And I'm going to go in here and define a color resource. So you open a tag, it's called color. And I'm going to name it white. And for the value, it's going to be just all X. So now how do I reference this? Back in my styles, I could say this one is going to be in my colors, and it's called white. And there we go. I've just referenced my own custom white color. Now let's see, what else am I missing here? So I want it to be size 20, that text color, font. I want it to be all caps. I want it to have that background. And I think I have everything I need. So why did I define the style? As you can see, there's quite a few attributes in there. If I had to do this for every button bar, it'd become quite tedious. But now that I've defined it, I can go here, get rid of this horrendous Android style, and I can define my own style here, button bar, and there is my style. So I've just styled both button bars with a single one. And that's the beauty of styles. You write it once and then you can use it everywhere. And if you come up with a good naming scheme, essentially your whole app is just styles. Alright, so let's see how this looks. Let's go ahead and run this, and it's going to run on the dock viewer over here. There we go. So I don't have anything in there yet. It's just the bar at the top and some empty list view. That's okay. That's no problem. Let's go back to our code and make sure you give everything an ID. So I have my linear layout button bar ID. I'm going to give this one an ID of grid button. And list button. Oh. Make sure you put that part, otherwise it complains. There we go. And I need to give a list view an ID. And I'm going to give it one of the standard Android IDs. It just makes it easier to find. And as you can see, it pre-populated it here because it knows what I'm trying to do. That's actually not going to show up. It's just to help you visually. So if we were to run this again, because the list view doesn't have any content to show, it's just going to be empty, just like we saw before. So there we go. It's still empty, still an empty list view. Can't do anything with it. All right, now that I've got that, we need to just start defining what goes in it. So if we go back to our activity, you can see that this is the auto-generated code. It created an activity. Here's my onCreate and some option menu stuff, which we're not using, so I'm just going to go ahead and delete. And then we have this placeholder fragment class that it created inside. The reason it did this is because our activity is simply acting as a content holder, really. So you can see here that it creates a layout activity sticky, and all it is a frame layout with nothing in it. Its sole purpose is to act as a container for this placeholder fragment. So you can see here we get the fragment manager begin transaction. We get the ID and we just throw it in there. So now we've got a full screen fragment, and that's completely okay. But that means that all of our code to handle this will actually go in the fragment. So everything that we do will happen within here. So within the fragment class, we're going to come in here and we're going to start getting our views. So we have a private list view, and we have another one which was our linear layout, which is a button bar. All right, we have those. And down here, it inflated our root view for us, and now what we're going to do is that we're going to inflate the other views. So our list view, and this is how you inflate anything with XML, is going to equal our root view, because that's the main view, and then we're going to call find view by ID. And what that does is it takes whatever view it's called on, and it's going to search its tree for the view with that ID. So we gave this view an android.r.id.list. And it's complaining because our find view by ID returns a view class. It does not return a list view class, but that's okay. We know what it finds is a list view. So I'm going to hit Alt-Enter, and my context-sensitive help menu is going to come up, and I'm going to say cast to list view. Great. Same thing with the button bar. Equals root view. And I called it button bar. There we go. So now I have both views. I have access to both views within my code, and that's how you find a view using XML. All right, great. How many of you have used list views? All right, good. So we all know that list view acts very different from like a scroll view, for example. It shows its content how? Essentially. And how do you tell it what content to show? An adapter. That's right. So we need to define an adapter for our list view. And instead of implementing list adapter, I know Matt had you implement list adapter. I'm going to do it a little differently. I am a lazy programmer and I don't like to do a lot of work. So I know that there's a class called array adapter that essentially has all the list adapter stuff implemented, but I'm going to customize it to do what I want it to do. So I'm going to set the list view adapter, and I'm going to make a new class in here. So let's go ahead and make that class. With our model, it's going to return a class that looks like this, objects that look like this, of type item. And it has two things, a link and an author. So that's the data I'm dealing with. So I need to create an adapter that handles that kind of data. And I'm going to do it my own way, so I'm going to implement my own item adapter. I'm going to extend array adapter of type item. I'm going to create a matching superconstructor, which will be this one. And in here, I don't care about that parameter. I just want the list of objects that it uses to take as an argument, and then I'll handle everything else from there. Now, whenever you're extending an array adapter, there's a very common design pattern that's used. It's called a view holder pattern. So I'm going to auto-generate some code here. And now that everything's imported, whenever you extend array adapter, you have to, at minimum, override getView. And this is how you define. So what getView does, it's called for every item within the list that was passed in. So if there's 20 items, this will get called 20 times. And you can see that its parameters are position, convert view, and parent. Position is essentially, the position of the item that is called in. And the whole point of this method is to inflate and show how that row is supposed. So each item here, the view that's returned is the row and how that row should look. So we can see that we have view equals convert view. There's a view that's passed in, and I'm just renaming it to row because it just makes more sense to me. And the way a view holder pattern works is, for example, if we go back to this example here, we have our banner and we have some other view down here, right? What the list view does is it says, okay, I have 10 items in the list. I don't need to create views for all 10 items. There are only 2 views on screen. I will create only 2 views. And as you scroll down and the first view goes off screen, what the list view will do is it'll take that view that went off screen and it's going to pass it in as convert view. So what the view holder pattern does is essentially one of the views went off screen, it'll now be recycled and given back to me. And my job while I'm overwriting get view is to reuse that view. And the way it's done is this pattern here. So we have an if statement that says row equals null. So if row equals null, that means the view was never created, so we have to actually create it. Okay. And we'll create it in here. And one of the final things we do is we call this method here called set tag. Yeah, but it's okay because it's null right now because I haven't done anything with it. But it'll be filled in, so this is to do, right? Fill in. Yeah, so right now it's null. And what this set tag method does is it accepts any object. Whatever object you throw in to get set to set tag, it'll be carried along with the view for the lifetime of the view. So it's really useful when a view holder pattern because if the row was not null, you can actually get that view holder out through the get tag. And what is the view holder? It's an image view and a text view, which is the only things I need to show for every row. It may be several more things, but for now, all I need is an image view and a text view for my purposes. So now the Android resources or the Android OS won't be creating views for every item in the list. It'll just be recycling the views. So it's a really nice memory management system. So here's what we're going to do. We have our view holder. Our row is null. So we're going to create a new view holder. And we're actually going to instantiate row equals layoutinflator.from. Okay, and I said we were going to use XML resources today, so that's what we're going to do here. We're going to inflate this row view from an XML resource file. Problem is, we haven't created it yet. So let's go ahead and do that. So we're here in layout, and this thing bugged. So we're going to create a new resource file, and we're going to call it row view, and I want it to be a relative layout. Okay, so here we go. Here's my relative layout. Now, how many of you are familiar with relative layouts? Like, feel pretty comfortable with it? It's a really nice system. It's very powerful. What it is essentially a constraint solver. So what we're going to do here is, let's say instead of a relative layout, let's say I had a linear layout. The way a linear layout works is it places one view, and then directly under it places the next one, and then directly under that places the next one, if it's vertical. But I don't want that to happen. I want an image to show up, and I want some text to show up directly on top of that image. If I use the linear layout, it'd appear below the image, but that's not what I want. I want it to be placed directly on top of the image, and I want it to be near the bottom of that image. So relative layouts are great for that, and I'll show you how it's done. So we're going to create an image view here. I'm going to say that the width is match parent, and the height I'm going to define as 200 dp. And again, I'm going to create a dimension resource out of this, and I'm going to call it row height. And the thing with image views is there's a few other things that I like to do every time just because image views are difficult to deal with in Android. So one of the things I do is adjust view bounds, and I set that to true. What that does is it allows the view area to be adjusted to best accommodate the image. So if the height of the image view needs to be adjusted just a little bit to accommodate the image better, it'll do it. It'll allow it to do it. Another thing I like to do is scale type. And what this does is define how the image will scale. So there's several different options in here. The one I like to use the most is called center crop. What this does is it maintains aspect ratio of the image and blows it up until it fits the entire image view area. And then if there's anything sticking out of that area, it's just going to crop it. The other option is center inside, and what that does is it shrinks the view until everything fits within the image view, and if there's any extra image view, it'll just make it transparent. So the reason I like center crop is because it fills in the image view area, and it keeps aspect ratio. So it looks really nice. It's at a good resolution, so that's the one I'm going to go with. And I'm also going to give this an ID, and I'm going to give it a default Android ID. of icon. Next thing is I wanted some text to be down here. So let's have a text view. I'm going to have it be match parent, and I'm going to have the height to be wrap content. All right. So a few other things I want to do. I'm not going to create a stylable for this one because I'm only ever going to use it once, so I'll just put all the stuff in here. So text size, make it 20. Text color, I'm going to make this white. So white resource. Let's see, what else do I want? I want it to be in caps. And one last thing, I want this to be at the bottom, stuck to the bottom of the row. So you can see here that I'm within the text view, and it's highlighting the area where it shows currently. This is the image view, and this is the text view. That's not what I want. I want this text view to always be stuck at the bottom. So because I'm in the relative layout, I could do this. Align parent bottom, true. And now it's going to be stuck to the bottom of the parent every single time. I could define this to be under the image view. I could define this to be above the image view, to the left, to the right, and that's the power of relative layouts. It solves the constraints, and it allows you to do some very creative things if you know how to use it. So there's that. I'm also going to do one last thing. I'm going to add some text in here just so I know what it looks like. Right. And because that can't be seen, background. No. Okay, so it's in that corner. That's not quite what I want. Let's give it some gravity, center. Okay, so now it's down there. Looks good. One last thing is I'm going to give it an ID. All right. So now I've got my row view all set up. So let's go back to my adapter and let's inflate this view. So there's the static class layout inflator dot from. I give it the context and I inflate r.layout dot row view. And it has two other parameters. It asks it for its parent, and it asks whether it wants this to be a new root view. And I don't want it to be a new root view, so I always send false. All right. Now I have my row inflated. The next thing I need to do is I need to get my image view and my text view. I'm going to say holder.imageView equals row.findViewById. I'll give it an Android ID. Okay, now inflated both my views, and I set the tag as the holder. So now that view is going to be recycled forever and ever. Now the last thing I need to do is, now that I have my views inflated, I actually need to set the data for each one of them. Because what's going to happen over here, if I recycle the views without setting the data for each new view, what I would get is this purple one would actually appear probably there, and then it would pop off screen and then appear again. And that's not what I want. I want to make sure that it's always showing the correct data. So this is the part where I would set it. So I'm going to go do holder, author, and before I do that, I actually need to get the item that contains the data. So item equals get item, and I pass in the position. So because I pass in the list of objects of list of items up here, I can then access it using this method. So now that I have that, I'm going to set the text to item.getAuthor. And my image, now if you've ever dealt with images, you know that they're kind of a pain to deal with. Like to load them into the image views and stuff like that, it's really a pain in the butt. So what I like to do is I like to use an image library. One of my favorite is, let's see, where are you? Is this library called Ion. Right here. And this website, it just gives you like the Gradle Maven compile tags. How many of you are familiar with Maven? Not really? Okay. So Maven is a dependency management system. Essentially, what it does is, well, I'll show you. If I open build, go in my dependencies, and normally this is where you would have to put everything for your library, jars and stuff like that. But because Gradle knows how to use Maven, I paste that in there, and there's one more thing I have to get. The support library, because Ion uses the support library. And now what this is going to do is it's going to go out to Maven and it's going to say, okay, I need to find the Ion library and the support v4 library. And what it'll do is instead of having to find the jars and all that stuff, it's just going to automatically go out to the internet, find it, and throw it into my project, and all done. I never have to worry about it.
Can you import JSON?
Yeah, same thing. Actually, if we go here, search JSON, there it is. Just throw that tag in there and it'll find it. And if you ever need to update to a new version, this part right here is the version number. Just bump it up a number and you're done. Yeah. Okay, so now that I have Ion, it allows me to do this cool little thing here. So ion.with, I send it the image view that I'm using. .load, I give it the URL, which thankfully is in the model, and I'm done. This will asynchronously go out and get the image. When it's done, it's going to load it into the image view, and I never have to worry about it. It's going to recycle it, it's going to cache it, it's going to do all the great things that I don't want to have to worry about. I think so. As long as the assignment does not deal specifically with how to handle images, yeah. For your final project, feel free. All right, so now my image adapter is set up. Looks like everything is there. My data is being changed, so now I actually need to use it. So here in my list adapter, new item adapter, I need to give it a context, and I need to give it my list of items, which thankfully the model provides. Just do model.getItems. Now this should be enough to, in theory, show the images. So let's see if that works. And Gradle takes a really long time every time you import a new library, so this could take a while. Which part? The holder is to recycle views, because the way the list view works is it only creates as many views as it needs. So if there's only 2 on screen out of 10 items, it'll only create 2. And so to save yourself from having to create 10 different views for every item that's in there, as you scroll off, it will recycle the previous view and then give it back to you and say, oh, here's the recycled view. Change the data. And that's all you have to do. What's in the holder? Yeah. Okay, so here we have it. We see that no images are loading, but we have the author name showing. So can anyone guess why that's happening? And we're getting these images from the internet. Can anyone guess why they're not showing? That's right, we don't have the permissions. I forgot to put the permissions in. So if we go to our manifest file, uses permission, internet, done. Now it should work. Let's see. And this is something everyone forgets so many times, and because I'm using a library, normally it would crash and say, hey, you don't have the internet permission. But because we're using a library, what it did was it caught the error silently and then never reported it. So a few things to keep in mind, but there we go. Here are the images. We have a different one for every item. We have the author name showing up correctly. And they're very, very high res, so it takes a few seconds for each one to load. They're several megabytes each, but they look good, so I like them. And then we can scroll all the way to the top, and it'll correctly find the new ones. Pretty cool, huh? So now that we got our image adapter working, what we want is this kind of behavior. We want a banner at the top, the sticky thing to be there, and the rest of the items. So we're missing a few things. Let's see. First thing let's do the banner. Now because we're doing this a little differently, for time's sake I'm going to not do some like some recommended ways of coding. So this view holder pattern is great when your data is uniform, but when your data is not uniform, it's going to screw it up. So now that we're adding a banner at the top, we no longer have just item objects in this list view. We have banner and item objects. So I'm actually going to get rid of this placeholder pattern, or view holder pattern, but keep it in mind. It's actually a great thing, and it'll help you with all kinds of memory errors. So I'm going to do this. If position equals 0, I know that I'm looking at the banner, which should be at the very top, and I want to do something different. Else, I'm going to do the rest. And I'm going to get rid of this part here. Okay. So we're looking at the banner. So what do I want this banner to look like? My row with the banner is going to be a new image view. And I'm not going to create XML out of it because it's very simple. It's not much. I'm going to set the layout parameters, and I'm going to have it match parent, and the height, I want it to be the same height as my other rows. So remember, I created a dimension resource so that I didn't have to remember what that height was. I just remember what the name of it is. So I'm going to go to my context and get my resources. And resources can be accessed from anything with a context. So within activities and fragments, you have direct access to resource. But because I'm in a custom class, I don't have that. So I go to get context, get resources. I get my dimension, and I know it's called r.dimension.rowHeight. And it's going to complain because it's a float. So you cast it to an integer. Awesome. Now I have my view inflated. The next thing I need to do is I need to actually set the image that's within it. Sure. Yeah, it will do. And there's the 2 parameters for it. Okay. So now I'm dealing with an image view. And one thing I really like to do is I want to make the scale type to be, what's it called? Center crop. So I'm going to say image view row dot set scale type. I want it to be center crop. Okay, so I've got that. The last thing I need to do is I need to give it the image to show. So I'm going to go back to my ion, and I love this thing. I'm dealing with an image view here. Dot load and model dot get model dot, where's banner? I think I copied the wrong one. Okay. Get banner. That's what I was supposed to do. So now it's going to load in the banner for me. Now, one thing to keep in mind, my data is no longer uniform. I'm kind of modifying the way array adapter works. So position doesn't quite represent what it should. Position equals 0 here. But down here, when I get the item, I've shifted everything by 1. So what I need to do is I need to shift it back to make sure I'm accessing the correct item in my array. So like I said, there are better ways to do this, but for the sake of time, we'll do it this way. So if I load this up, I should get my banner at the top and the rest of the items at the bottom without crashing. So yeah, I'm not recycling the views because the view holder pattern works with uniform data. But and I'm changing all this up, so there are better ways of doing this, but I just don't have time to show it. So here we have my fuzzy monkey, which is the banner. And I have the rest of the items below it. And you can see it's not crashing, it's still loading everything. It still takes a few seconds for each item, but it's good. So, now what we need to do, there we go, yeah. So everything's showing up correctly. I still have this button bar at the top. And the behavior we want is this one. We have a banner, a sticky header, and the rest of it. And you can see that this sticky isn't on top of the banner area. It's not on top of the next items area. It's actually within its own space. So we need to take care of that. Now the thing is, to do that, it's a little tricky. It's not super complex, but it is tricky, and it has to be custom. So this example works with a scroll view. But as I said earlier, scroll views are only so useful, so we need to adapt it for a list view. So that's what we're going to do today. We're going to adapt that for a list view. And what we need to do, if we think about it, we need to know, to move this correctly, this banner correctly, we need to know when the view is scrolling. Unfortunately, there's no way for either the list view or the scroll view, there's no way to access it directly and say, hey, are you scrolling? So what we're going to need to do, we're going to need to extend list view, go to one of its internal methods and create a callback for when it's scrolling. And that's what we're going to do. It's not too difficult. So we're going to go in here, we're going to create a new class, and we're going to call it observable list view. It's going to extend list view. I'm going to have the constructors for it there. And the method I'm going to override is called onScrollChange. All right, I'm going to override that one. And this is an internal method. I don't have access to this anywhere else, but I'm going to open up access to it, which is why I call it observable. So before I do that, I'm going to create my interface. And I'm going to call it onListViewChange. It's going to have a single method, listViewChanged. And the way listeners work is you always have the private variable of that type at the top. So onListViewChange. And then in here, I'm going to actually call it. So as long as it's not null, call it. And that's all I need. The reason that's all I need is because I'm going to handle the logic of how to respond to it somewhere else. But all I really need is I just need to know when is this view scrolling. And we'll see how that works later on. So now that I have that, I'm going to go back to my sticky, and I'm going to change this list view to an observable list view. And don't forget to go back to your fragment layout and actually change this part to observable list view. Otherwise, it'll crash horrendously. So now I'm dealing with an observable list view. I'm going to have this fragment implement the onListViewChange. Alt-Enter brings up my help menu, implement methods, that's what I want. And for now, we'll leave it to do. We'll worry about this in a little bit. So, going back to our example here, you'll notice that, again, this isn't taking up space of any of the views. But the one that we currently have blocks the top part. Wherever that button bar is, it's blocking the top part. So what we need to get it to do is not only to respond to the scroll, but to make sure it's not on top of any other view. Anybody have an idea on how we could do that? All right. So what we're going to do is we're going to actually have a placeholder view that's directly under this. So our second item in the list view is going to be a placeholder view. It's going to have nothing in it. It's going to be the same size as the button bar, and its sole purpose is to tell the button bar where to go. So let's go ahead and do that. We go back to our item adapter. We're going to have another else statement in here. Else if position is 1, so now we're in the second item in the list, which is going to be our placeholder. So we're going to have our view be a new view, our row be a new view. I'm going to set the layout params to be, actually you guys want this in there. Yeah. I'm going to have match parent. There we go. Match parent. And the other one is going to be the same size as the button bar. Now I also have that in a resource file, r.dimension.stickyHeight. And again, this is going to contain, there we go. So what I've created is I've set the layout params to match the parent width, and to be the same height as that button bar, which is very important. The last thing I'm going to do is I'm actually going to save that view. And I'm going to add a getter for it. The reason I'm going to do this, and this only works because I'm not recycling the views anymore. So the reason I'm doing this is back in the sticky, I need to know where that placeholder view is. So I'm going to get my list adapter, I'm going to get the adapter. I actually need to cast this to a item adapter. I'm going to get the placeholder. The reason I'm doing this is I need to know where that placeholder view is so I can tell my button bar where to show. And this is how I'm going to do it. I'm going to go to my button bar and I'm going to translate Y. Does anyone know what that method does? So here what the doc says, it sets the vertical location of this view relative to its top position. So here's what we know. The button bar is currently at the very top of the parent, of the view, right? What set translation does is it translates it negative, which makes it go up, or positive, which makes it go down. And 0 is back to its original position. So what I want this to do is this. Math.max between 0 and placeholder.getY. Can anyone guess why this works? So if we remember, 0, 0 is actually this top corner. Let's say this was 100 pixels wide, 100 is over here. So when you go off the screen up, it turns negative. When you go down, it's positive. So what's happening here is we know our button bar is like this right now. This top pixel is position 0. And we know that there's a placeholder view directly under this. So right now, this placeholder has a positive Y position. When we scroll off the screen, the placeholder view is still up here. So it's actually off screen up here. But it has a negative position because it went off the screen. So now what we do is we get math.max. We want this bar to either be at the very top, position 0, or if it's positive, follow the placeholder. And let's see, and then that should take care of everything. So if we run it now, everything should work. So there we have our placeholder, we have our other views, but for some reason that button bar isn't following it. It's fine when it's up here, but it's not following it there. Can anyone guess why? It has to do with the listener. Nope. So it's actually a very common problem. We all have done this more than once, I'm sure. It has to do with the listener. So we have it getting called here. We're having it implemented. We've implemented it, but have we set the listener? We haven't. And that's what we need to do. We need to go to listview.set. Did I put it in there? Yeah, I didn't. There we go. What is it, list view? What do I call it? List view. Oops. Yeah, and this. So now I've set the listener, this should get called, and now everything should work. There we go. It looks like it went down to where it's supposed to be. We scroll up, it sticks to the top. We scroll down, and it follows it. And we quick scroll, and there it is. and now you have a sticky view, sticky header that you can use in your final project. And it's used quite a bit, but it isn't seen as much in Android. So I think if you would have added it to your final project, if it's relevant, I think it really gives it a very nice feel to it, very professional. Any questions? Yeah, so array adapter probably wouldn't be the best way to handle it because the array adapter assumes a uniform data set. So if you look at array adapter, when you extend it, you're telling him the type of the data you're dealing with, and that's the whole point. You're dealing with a single type of data, so when you recycle it, everything works fine. And actually, I think I forgot to do one thing here. That should be it too, because we added another item. So I think the reason that didn't pop up and kill us is because we haven't scrolled to the bottom or something. But anyways, yeah, we've shifted it too, so that should be 2. But the point is, back to the uniform data. Array adapter, that's the whole point of the array adapter. You're dealing with a single type of data, so that means you could always recycle it and just change the data for the views. If you were to do this differently, you would probably implement list adapter and then handle the memory management on your own. It can still be done with a view holder pattern. You just need to take into account that sometimes it'll be a banner, sometimes it'll be a placeholder. And I have it implemented on some other code for a project that I did, but it's a lot of code. Yeah, but this is something that, the reason I show you guys this is because I had to do this for a project. The iOS version had this implementation, and I tried to find a way to do it in Android. There was no way to do it. iOS does it out of the box. So I had to do this custom, and the only demo I found did it with a scroll view, which serves no purpose for me. So I had to figure out a way to do it with a list view. Yeah.
So what those photos are being loaded right now, how they fade in,
Mm-hmm.
is that part of how Android handles images or how this library?
I think the default is a fade-in animation.
So if you just say like, do that set,
Yeah, you could actually, I think Ion has a .animate, animate in, animate load, and you just give it the type of animation.
like this.
Yeah, it does quite a bit. It's not just images, it does more, but it's very powerful for images. Yeah, so you could have it fade in, you could have it like scroll or like translate in from one of the sides or top, or do like a corkscrew type thing. Yeah, you could have it. Yeah, you could have it do however you want. It's really cool.
So is this media for studio set?
Yes, it's exactly what NuGet is. Mm-hmm. Yeah. Any other questions? All right. So yeah, that's all I have for lecture. You guys still have about 10 minutes. I'm open for questions until then. Other than that, that's the end of lecture. All right. You guys have a good day.
I have a question about the network API for the battleship assignment.
Okay.
So
One second, I'm just trying to. I don't think this recorded. Great.